Okay, lesson 53, we're going to be talking about angular velocity, which is the rate at which something spins. To get ready to do these problems, we just need to make sure we all remember how to use unit multipliers to convert different kinds of rates. All right, so if we wanted to convert 50 miles per hour to centimeters per minute, let's remember how we do that. So if I have 50 miles per hour, what I want to do is change my miles to centimeters and change my hours to minutes. So to do that, I have to know how to convert those things. So first of all, the only metric to English conversion that I have memorized is that there are 2.54 centimeters in an inch. So I'm going to take these miles down to inches and then change them to centimeters. All right, so I'm going to do that because I know that there are 5,280 feet in 1 mile. So that's 5,280 feet per mile. All right, that means miles on top, miles on the bottom, the miles cancel. So I'm at feet. Now I'm going to go to inches. There are 12 inches in 1 foot. All right, so feet on top, feet on bottom, cancel. Now I'm going to change to centimeters. There are 2.54 centimeters in 1 inch. Inches on top, inches on bottom, they cancel. So I'm at centimeters. Now I just need to change hours to minutes. There are 60 minutes in 1 hour. And since the hours are on the bottom, I want to put hours on top. So 1 hour, 60 minutes. So the hours on the bottom, hours on the top cancel, and I'm left with centimeters per minute. So I would have to multiply this out. I would multiply 50 times 5,280 times 12 times 2.54 divided by 60. So that would be about 134,112 centimeters per minute. Okay, so if you know how to convert different kinds of rates using unit multipliers like that, then angular velocity will be pretty simple for you. All right, so angular velocity is the rate at which something spins. So it's measured in degrees per second, degrees per minute, radians per second, radians per minute, revolutions per second, revolutions per minute. Okay, it's the rate that something goes around and around and around. The linear velocity, which is the kind of velocity we usually talk about, miles per hour, centimeters per minute, whatever, that linear velocity of a point rotating on a wheel depends on the rate of rotation, that is angular velocity of the wheel, and it also depends on the distance of the point from the center of the wheel. So if you look at this wheel here in this picture, you've got a point P and you've got a point Q. P is actually, its linear velocity is much faster than Q's because every rotation P goes a lot farther than Q does because it's on the very outside of the circle, which is a bigger distance to go. Q is closer to the center. It's the radius of its circle is smaller, so it goes less distance in the same exact time that P goes that bigger distance. So P has the greater linear velocity, even though P and Q both have the same angular velocity. They're spinning at the same rate. They're both on the same circle. But Q is closer to the middle, so its path is shorter. Therefore, it is not making as much, it's not covering as much ground as P is in the same amount of time. So the linear velocity of P, if you think about it, all right, this is, let's see, suppose the wheel makes 1 revolution per second. All right, so 1 revolution per second. Well, how far does P go in 1 second? Well, P is on the circle whose radius is 10. That means that P goes 2 pi r, that's the circumference. So 2 pi times 10 inches every second because it goes all the way around the circle every second. So it goes one circumference, so 20 pi inches per second. So the velocity of P is 20 pi inches per second, because this wheel goes around once every second. The linear velocity of Q is only 10 pi inches per second because the radius of the circle that Q is on is just 5. So 2 pi r is 10 pi inches per second. So you can see that P is actually going faster linearly, even though P and Q are spinning at the same rate. So they have the same angular velocity, but their linear velocities are different. In general, the linear velocity of a point on a rotating body is v equals r omega, where r is the radius, that's the distance of the point from the center of the circle, and omega is the angular velocity measured in radians per unit time. Okay? We're not really going to use this formula because this formula is only good if you have the angular velocity of your wheel or whatever it is that's spinning in radians per unit time. But a lot of the time it's not in radians, and so you end up having to change it anyway. So we're just simply going to use unit multipliers to change our units of velocity. So if you try to use this formula at this point in the way the problems are going to be, it's going to confuse you. So don't even worry about that formula right now. You can save that for your physics class, whatever you want to do with it, but it doesn't really help us that much because of the way the problems are structured in this book. All you have to do is use unit multipliers, okay? So it's very simple. The wheel of a wagon has a radius of 14 inches and is revolving at 40 revolutions per minute. How fast is the wagon moving in miles per hour? All right, so they give us the angular velocity and they want us to find the linear velocity. So 40 revolutions per minute. So that's what we're starting out with, 40 revolutions per minute. And we want to change this to miles per hour. All right, so it's easy to change the minutes to hours. We could just go ahead and do that. So we want minutes on top, 60 minutes in 1 hour. So the minutes will cancel. All right, now we want to change revolutions to miles. All right, well, they're telling me that the radius of the wheel is 14 inches. So a revolution means one spin. One spin of the wheel is the circumference. That's how far the wagon goes when the wheel goes around one time, is the circumference. So the circumference of the circle, remember, is 2 pi r. So 2 pi times 14 inches per revolution. That's just circumference, one circumference per revolution. So 2 pi r inches per revolution. That'll cancel my revolutions. All right, now I need to get this to miles. I've got inches, so I'm going to have to get it to feet. So there's 1 foot in 12 inches. That's going to cancel the inches. And then 1 mile, 5,280 feet. That's going to cancel the feet. All right, so I'm done. I've got miles per hour. All right, so it's just very simple. There's no need to learn a formula. You just use your unit multipliers just like you normally would. If you are dealing with revolutions, a revolution is just a circumference of the circle, whatever circle you're dealing with. All right, so we can multiply this all out. 40 times 60 times 2 times pi times 14 divided by 12 divided by 5,280, and that's about 3.33 miles per hour. All right, let's look at another example. All right, an automobile whose wheels are 30 inches in diameter is traveling at 40 miles per hour. What is the angular velocity of the wheels in revolutions per second? All right, so we've got 40 miles per hour, miles per hour, and we want to get revolutions per second. Let's go ahead and change the hours to seconds. All right, so 1 hour is 3,600 seconds. So that's good to go. Now we've got to change miles to revolutions. All right. Now, what do we know about revolutions? We know that the wheel has 30 inches in its diameter. All right. So remember, pi d is another way to talk about circumference. So one revolution is one circumference. So pi d, so 30 pi inches per revolution. All right. So we want revolutions on top because we want revolutions per second. So one revolution is 30 pi inches. That's just one circumference. All right, we want, we can't cancel the inches with miles because they're different. So we have to get inches to miles so that those will cancel. All right, so there are 12 inches in 1 foot. So 12 inches in 1 foot. And then 5,280 feet in 1 mile. So the feet cancel, inches cancel, and our miles cancel, and we're left with revolutions per second. So we're going to multiply 40 times 12 times 5,280 divided by 3,600 divided by 30 divided by pi is about 0.134 revolutions per second.